Hello, good morning everybody. Today we have been assembled here to discuss a very important issue about the construction of the road, which is the bituminous mix design. More than 90% of the highways across the world, including our country, it is built with the bituminous pavements that we popularly call as the flexible pavement. And the designing of the bituminous mix design is a very delicate thing. I will discuss that. So today, as a specific presentation on the asphalt mix design that you can see here, I'll be sharing all these documents will be shared with you, and along with that, some 3 other presentations are there. The relevant portion I will try to show, and documents which will be shared and shown with you, shown to you. That is this thing, Asphalt Institute Manual MS2. It is the basic of the asphalt mix design. This one is the sixth edition. Okay, this is the 6th edition. If you would like to see on this thing. Okay. And then it has been updated to 7th edition. Around 10 years ago it has been published, and there are much improvement with some additional chapters incorporating the super pave and wrap, that is reclaimed asphalt pavement design with that, mixed design with that. So this is the 7th edition. This is the book MS2 7th edition, and there are Indian standards also, IRC. This is actually this is not the mixed design description. IRC 111. That is the specification for this one, and of course the 5th revision are there. 5th revision, Ministry's 5th revision is their orange book, what we popularly call. And these codes are actually, guidelines are actually for the range specification of the ranges. The detailed description how to do the mixed design, that is mainly described in MS2. That 2 books I have shown you, and this is 111, and recently IRC has also published this document, IRC SP 135. This is the manual for the design of the hot bituminous mixes. So this document, I will also discuss a bit of that particular points out of it. And this document will also be shared with you. And lastly, very important document and very advanced document, that is NCHRP document 673. This is the very advanced document. This MS2 6th and 7th edition is more than enough if you want to understand the delicacy of the asphalt mix design. But people who are interested in advanced studies and further studies, this is the book. This is the book. Other document. It is not IRC, NCHRP document. It's American specification. These are available in the your internet. However, I am sharing all these soft copies will be shared with you. No problem. So let us start with this one. And also the soft copy is of course not there. And this is a very good book written by Professor P.S. Khandal, Professor A. Vidagavan, and Professor Rajan Chaudhary. This is also very good book. Professor P.S. Khandal and Professor Vidagavan, they are well-known faces in this field, very renowned, very respected Professor P.S. Kandal, he is actually Indian origin, asphalt scientist, I can call. So he has practiced almost 35 years in US. There are many research papers, manuals are there published by him, and importantly, one textbook written by him along with Roy Brown, something and others. That textbook is followed as the textbook of this bituminous mix design across all the continents, Europe, America, Asia, Africa, Australia, New Zealand, everywhere. That book is considered to be the very unique textbook on this subject. And now Professor Khandal is living after his tenure in the USA. He was there in the associate chairman or something like that in INCAT. Is the world #1 asphalt research institute of the world in US, National Center for Asphalt Technology. And he's also maintaining that, but he's now living in Jaipur and he's very active, and he has written this book. And I am that way very fortunate to be closely associated with him. Some research papers are there with him, and I have learnt a lot from him. And another person I should take his name also with my respect and honor, that is late Professor B.V. Pandey of IIT Kharagpur. I have also learned a lot from him, and also very fortunate to be closely associated with him. Apart from them, these two stalwart persons, Professor K.S. Reddy, Professor Rajib Basu Mollik, and then Professor Amarnath Reddy, Professor Krishna Prapurna Biligiri, and now Krishna Kranti Kuna of IIT Kharagpur, Krishna Biligiri is of IIT Tirupati. With all these persons, and Professor Murli Krishnan of IIT Madras, all these persons they are stalwart and expert in this field. I have interacted a lot with them, and whatever I could gain my experience out of my almost 4 decades of this of my service. Now also I am also associated in this industry itself. I'll try to, with the request of our colleagues, I am trying to share my experience about this very, very important aspect. So this presentation, originally it was made way back, almost 15 years back or something like that, when I was actually executive engineer of Bankura division. This road is of Bankura Durgapur road. There we were executing the project Bankura Durgapur road. So at that time it was actually the presentation was actually made, and now after that it has been some incorporation was made with some modification like that. So let me start the mix design process. Asphalt mix design is a very delicate engineering activity, very, very delicate. It is not so easy. Normally we can think, or the common people can think, what is there in this engineering? There are stone aggregates, there are bitumen that is mixed and that is laid. What is there in the engineering? But there are many, many delicate and very, very high level engineering is there for constructing a very durable road. Now the beauty of the asphalt mix design, whatever you call it, you can call it beauty, or it has to address many criteria like your strength of the road, the stability, the durability, the impermeability, the workability, the surface skid resistance, then resistance against fatigue cracking and rutting These two are normally these two are the failures, the fatigue cracking and rutting. We have an appearance also. There are many other things, and in these, all these actually, what I have just now told, and it's shown in the screen, many criteria are such that they are contradictory to each other. How to address this is the delicacy of the asphalt mix design. Like your fatigue cracking, it increases when the bitumen is less. Okay. But at that same time, it is a bit better as the rack resistant. But on the other thing, if you want to address the fatigue cracking, then higher bitumen content is better. But in that case, it will invite the rutting. So these two, the fatigue cracking and rutting, they are the main defects and faults of the asphaltic road. But in the asphalt mix design, you have to address these two. But the actual requirement, by what you will be addressing these two main failures, these are just contradictory to each other. So asphalt mix design is a very, very delicate balance you have to do. It's a very narrow range within which both these criteria can be satisfied. So that we will try to discuss in today's deliberation. But the fundamental performance properties are not measured in the design mix. Like the performance properties, how it is, this thing means fatigue, cracking and rutting. These are actually by the parameters of the mix design, those are not directly measured. However, in modern times, the performance mix designs are there. I will also come to those points. But those are indirectly assessed by some empirical parameters. Empirical parameters like what we have called, we know the volumetric properties, that air void, voids in mineral aggregates, like that, and also some very arbitrary parameters which can be measured, like your Marshall stability or the flow, like that. But okay, we'll come one by one and we'll discuss. The aim of the mix design, the parameters which have to be taken into account to achieve the desired criteria are sufficient asphalt or bitumen in the mix to ensure the durable pavement, sufficient voids in the compacted mix to allow a slight amount of expansion of the asphalt due to increase in the temperature, and also by the action of the additional compaction under the effect of the traffic movement, especially in the summer season when the viscosity of the binder comes down actually in the summer season, because we all know the bitumen is sensitive to temperature. It is a viscoelastic material and sensitive to the temperature. So in the summer season, when the ambient temperature goes up, its viscosity comes down. So at that time, when the traffic is moving on the road, actually bitumen is trying to ooze out from the spaces. So to accommodate that, it should not come totally out of the system. So to accommodate that, we need some special design. And that is what all about this asphalt mix design. And that we have to do it without flushing, bleeding and the loss of stability. So these are the aims of the mix design. If you have questions, to make it interactive, you can stop me and ask questions wherever you have any doubts or any questions, whatever. I don't mind. And that way it may be interactive, because it is no time bar is there, so we can discuss, and you can feel free to ask me questions wherever you feel any doubt. The maximum void content in the mix to restrict the ingress of the air and the moisture, causing early aging of the binder. We have some design voids in the asphalt mix, but that should not cross some threshold limit, so that ingress of the water and air will be there, is entertained. And if we know the water is the enemy of the bituminous, because it is decreasing the adhesion power, gluing power of the bitumen, and it is dislodging the aggregates from its system. So incorporation or ingress of the water, it causes that damage of the bituminous pavement. Also, if the air is also ingressed in the system, actually with the ingress of the air, the bitumen, the binder of the system, it actually oxidizes the bitumen, and in that case it ages out. And with the aging of the bitumen actually losses is binding or gluing power. It turns from the ductile to the brittle. So we don't want. So we have some threshold limit of the air void, so that the voids are not interconnected, and the water and air should not ingress in the system. The next is the sufficient mix stability to satisfy the demand of traffic without distortion or displacement. Sufficient mix stability. Naturally, if the traffic is moving on the road, if it is means stability is not enough, sufficient, then it will move, and that we don't want. Sufficient workability to permit the placement without any segregation and without sacrificing stability and performance. Naturally, during the construction also we need some workability, like for the cement concrete works, we also need some workability while placing it during the construction. We have to have sufficient skid resistance also. This is a very, very important safety aspect for the bituminous pavement. While the your traffic movement is carried on through the bituminous pavement, we need to apply some brakes for stopping the vehicles. If the friction, the skid resistance with the pneumatic tire and the bituminous pavement is not enough, it will skid. Naturally, if you have some experience in visiting some hilly areas like Kashmir or even Darjeeling, and if some snowfall is there, the vehicles, if it is moving on the some little snow or the frost form, what will happen? Without having the proper grip, should we feel enough safe? No. So that way, actually, the skid resistance, proper skid resistance of the bituminous surface with the pneumatic tire, it should be there. It is a very, very important safety aspect. That is also addressed through your mix design, proper mix design. And also, lastly, the good appearance and noiseless, smooth interaction with the pneumatic tire. In concrete pavement, what we feel, this noise with the pneumatic tire, that is actually it is more than the bituminous. So that is the disadvantage of the concrete pavement. One of the disadvantages of the concrete pavement. And in abroad, where the concrete pavement is there, we often see there are noise barriers in between the road and the habitation area to just obstruct the noise that is occurring. So in bituminous pavement, this is one advantage, that the noise that is occurring for the rolling of the pneumatic tire and traffic movement, that is lesser than the concrete pavement. But we need to do the proper mix design. An ultimate objective of the mix design is to determine a cost-effective blend of the asphalt and the mineral aggregates, including the filler, if any, with appropriate gradation, which will yield a durable and serviceable pavement. Naturally, it is the actual mixture of your binder and the aggregate, different sizes of the aggregate. Actually, different sizes of the aggregate, it forms the structures, the skeleton of the top surface or the immediate bottom surface, that is the we call it base binder course. The skeleton is just held in its position with bitumen as the binder that is acting as the glue. Okay, and it is supposed to be cost effective as well, because everything is determined after all ultimately by economics. So it should be cost effective as well. And this is the ultimate objective, that it should be durable and the serviceable. Okay, for the time for what we have actually designed. Now there are methods for the mix design. There are initially there are two methods: the Marshall method and the beam method. There are designated ASTM codes. For Marshall method, it is ASTM D1559, and MS2 is also there. For beam method, there are ASTM D1561, and MS2 also covers that. After the Second World War, or just before the Second World War, these two methods actually invented during the time of that. Means lot of destruction that happened, and the world, advanced world that way, actually needed the lot of road infrastructure to be built. And that time, Marshall method was invented by Bruce Marshall, and beam method was invented by Francis N. Pym. Both were invented in USA. And after that, in 1987, the superior performing asphalt pavement, in short it is called super pave mix design, that came into place. And from early 90s in USA, the Marshall method replaced by the super pave mix design. But in several other parts of the entire globe, including Europe, in our country, in Africa, still Marshall method is very popular, because it is not lot of your laboratory equipments are required. It is sort of easy method to understand and do that. And in our country also, in this code ISC SP 35, it has incorporated a bit of super pave mix design, but it has not become that popular in our country. So we will be mainly focusing the Marshall method, which is being used in our country. And the latest trend in the world, that is the balanced mix design. This is this is a performance based mix design, where what we have already discussed, that is cracking and rutting, these two conflicting criteria has to be addressed. And you can see in this narrow range, this is operating. This is a narrow range. Oh, it has aura also. So in this narrow range, it is actually both the criteria are being satisfied. So the it is very delicate to determine the actual design bitumen content, what will be doing in the bitumen by the bituminous mix design, to address both of these two conflicting characteristics or the criteria. Why Marshall method? Out of these 3 or 4 methods, Marshall method is being used in India like most of the countries in the world. It was, I have already discussed, it was also used in the most of the states in US till the super pave has come in force. Marshall method is popular because its testing methods are simple, equipments are not costly. Since Second World War, Marshall method has been successfully applied all over the world. Super pave is a superior method, of course, but the instruments which are being used, laboratory instruments which are being used, those are costly. Gyratory compactor, and most importantly the DSR, direct shear rheometer. So those are costly equipments. And we have told the Marshall is still the method which we are applying in our country, so we will be discussing the Marshall method. The asphalt mix design means to determine proper blend of the mineral aggregates with the filler, of course, if any, fillers if any, to form a durable skeleton structure to provide an uniform bed for a safe traffic movement with bitumen, the binder which is acting as a glue to hold the aggregates in place so that the skeleton structure of the aggregate does not break easily under the effect of the traffic and the weather. There are traffic supplying and there are weather elements like your rainfall, the sunlight with the ultraviolet light of the sunlight that actually ages the bitumen. I have told there are many factors which is actually acting as the aging of the, we are like on our human body also we faces this and we are aging, bitumen also ages. But if it is protected from all this, bitumen is a very durable. I can say tell you some stories out of bitumen. The mummies, purification means protection of the mummies, how it is preserved. Sort of bituminous resin, those are used for the protection or preservation of the mummies. And in our Mahabharata, we all know there were stories where the Pandavas were put in the Jatugriha, okay, and that were burnt overnight. The Jatu means is actually the it came from the French word actually. It's rather from this Sanskrit word Jatu from there actually this bitumen has come from the French to the English it has come. So that was also sort of bituminous thing. It was the house was made with the bituminous glue sort of so. So there is one article written by me for the bitumen that is available in the academia.edu. There the story is there. Interesting one. The combination of the right proportion of the different sizes of the aggregate is called the aggregate gradation, which is an important part of the mix design. Normally what we actually understand means asphalt mix design means only to determine the optimum bitumen content. It is not. The aggregate gradation is a very, very important part of the bituminous mix design. So it has also lot of implications on the bituminous mix design. It has sufficient influence on the stiffness, the stability, durability, permeability, workability, fatigue resistance, rut resistance, skid resistance, everything that I have discussed already, and resistance to the moisture damage. Theoretically, it would seem reasonable that the best gradation is one which gives the densest aggregate gradation. This is very interesting because what we normally try to do in case of the soil for compacting soil, we try to compact it to the densest form, as densest as possible we can. But in case of the bituminous mix, we keep a designed air void. That is the difference between the soil compaction and the bituminous compaction. So we do not intend to make it to compact it in the densest form. We'll try. We'll discuss about it. Why it is actually we do not want the densest form packing. We will not have the densest packing of the aggregate gradation. We actually in asphalt mix design, we actually leave some designed air void in the mix. Unlike your soil compaction. Soil compaction also there are air voids because we cannot compact it to the zero air void. In zero air void that is a theoretical concept. We all know zero air void line. We all know we have studied in the soil mechanics. But here it is further improvised. And what was your question? Tell me now. Actually, skeleton structure is not that way affected by the weathering action. Because of the rain, and if some water gets inside your bituminous pavement, and for the traffic blind, if some pores are water gets entrapped inside the bituminous pavement, then with the action of the traffic, some hydraulic action like some balloon, if it is pressed and some pressure is created, and the aggregate particles is you understand, because of the pressure created, the particles try to dislodge from their position. But here comes the action of the bitumen. Bitumen acts as the glue. It actually holds the aggregate skeleton structure in its position. With the action of the water or other weathering actions like your sun rays, mainly these two, when the gluing action, it is edges and gluing action reduces. So when it happens like that, so this under the action of the traffic, when it is dislodged, means easily it will be dislodged, the aggregate skeleton structure. From there actually this is the starting of the formation of the potholes and other distresses. Okay, I think I could address your point. There freeze and thaws action is there, but in our country, apart from some few hilly region, this phenomenon is not that prominent in our country. In USA or in Europe, this happens. The basic concept is continued. The trick of the mix design for the dense graded mixes, there are other variety of the mixes like we have experience in recent times, like your SMA mix. Those are gap graded mix. That is different. We are now discussing the dense graded mix. Is to find such a gradation which will yield not the densest packing but will have sufficient voids. That is called voids in mineral aggregates. In short, it is VMA, to accommodate enough bitumen for ensuring durability against the fatigue cracking, as well as, most importantly, some specified amount of the voids, which is called air void or void in mix, to allow the expansion and expulsion of the bitumen during the summer under the action of the heavy traffic, to ensure resistance against the rutting, flushing, bleeding, etc. This is different from the densest aggregate gradation that I have told. So here we are keeping some designed voids in the asphalt mix to accommodate the expansion and expulsion of the bitumen to be accommodated within the system. Otherwise, if we don't keep enough void designated or designed air void, it will expel from the system, it will not come back, which is actually the bleeding. What we see, the fatty surface, bitumen comes out, and where it is observed, and after 2-3 months the rutting will form, which is called the plastic deformation. Plastic deformation, like in the metal, there are two deformations or two things, means elastic deformation and the plastic deformation. What we call elastic deformation is that the deformation under the action of the stress when it is applied, and when the stress is withdrawn, it comes back to original position. Within certain limit, it will come back. If it crosses that limit, the threshold limit, it will not come back. Some permanent deformation is caused, which is called plastic deformation. Here also, in this bituminous mix also, this plastic deformation occurs if the bitumen is expelled from the system, and it happens when some minimum air void goes beyond the threshold limit, which is normally 3%, 3 to 2.5%. That is very interesting. There lies the delicacy of the asphalt mix design.
Sir, যদি আমরা যখন একটা বিটুমিনাস মিক্স ডিজাইন করছি রে করলাম, যদি কোনো কারণে অনেক সময় তো হয় বিটুমিন কন্টেন্টটা সবসময় রেস্ট্রিক্টেড করা যায় না, অনেক সময় একটু বেশি হয়ে গেল, সেক্ষেত্রে তো ব্লিডিং হতে পারে।
Yes. Yes.
তাহলে সেক্ষেত্রে যদি সেই রকম যদি কোনো কেস হয় তাহলে সেক্ষেত্রে কি রোড রাস্তাটা যেটা আমরা তৈরি করলাম
Excess bitumen is also not good. If generally it does not happen, people are not interested or interested in giving the incorporating more bitumen. The contrary will happen, lesser bitumen, and for lesser bitumen, the other problems will happen. That I have told you means is fatigue cracking or the raveling, the stripping of the aggregates from the mix. Those happens. So it's a very narrow range of the bituminous content also and the air void also. If within this narrow range, both upper and lower, if it is crosses beyond the upper and lower range, some other problems will different problems.
একটা অপটিমাম বাইন্ডার কন্টেন্ট অপটিমাম বিটুমেন কন্টেন্ট একটা প্রশ্ন চলে আসছে এখানে
Yes, that is what all about the asphalt mix design. That is for the asphalt mix design. We are actually determining the optimum bitumen content or the design bitumen content. And normally we have this conception that asphalt mix design is all about to determine the optimum bitumen content or design bitumen. It is not. The other very important part is the aggregate gradation that I want to address, want to share with you. Okay, so let us move forward. Up to this, if anybody of you have any questions, you can make it interactive, whatever. If you feel free to ask any questions.
Sir, actually, in plastic mix design, the air void is lesser than the.
Not lesser, it is zero.
It is zero.
It is zero.
And it will perform durability is more
Yes,
than this.
yes, yes.
What is the cost?
What is the cost?
And
Okay.
if we
What is the difference? You can see.
Yes.
What is the difference?
If we proceed the mix design with a zero air void, it will last long, I think.
Because bitumen doesn't get any chance. This ingress of the water and air, it is blocked. Okay, and bitumen is preserved. Okay, so it's a good question. What is the difference? Then why we should not go all the mixes as the mastic asphalt?
Right.
Okay,
Right.
why not? Mostly the bitumen content with the dense grade bituminous mix like your DBM and BC. For DBM it is generally 4.5% the base course, and the upper course it is 5 to 5.5. Same, okay. For mastic asphalt it is how much? 9.5 to 10%. So much more, so costly also. And the mastic asphalt is having zero air void theoretically. Okay, it's not because of the higher bitumen content only. Actually, this mastic, the means mortar, which is formed by the higher bitumen content, or also the higher lime means filler content, which is lime generally. So with this too, the mortar is having the base or matrix like that. It is having the zero air void. There is no air void. Means the bitumen means no percolation of the air and water is there, and that's why, as because your bitumen content is much more, so it will have the chances to flow. That's why for the mastic asphalt you need some very hard grade of bitumen, not the normal rigid grade bitumen. There we are using the industrial grade bitumen. There the penetration grade is much means actually lower, the value is lower, but actually it's much harder. Okay, so there is the beauty. One thing why we are not using the mastic asphalt as because of the greater bitumen content, greater lime content, that it is costlier. Okay, and there are some limitations in form of your riding quality. So for what we are actually using the mastic, which is a manual in form, and thereby we are incorporating some manual anti-skid materials. But those, if the bitumen is a bit softer and your with some weather variety or something like that, there also very delicate range is there. If it is crosses or goes beyond that range, actually the anti-skid stone aggregates penetrates down. So it will not have enough grip with the pneumatic tire, and the skid resistance that I was talking about, that losses actually. So the safety issues are there. So for the mastic asphalt, there are speed restrictions. So far, what I am talking about, that is the manual mastic asphalt. So their maximum speed limit was 50 km per hour. But we have overcome that. In Europe, it has started with the mechanical version of the mastic asphalt, and there the skid resistance are being done with the continuous anti-skid, not by just manual grafting. It is continuous. That we have also executed in the roads of Kolkata, second of its kind in the country. Successfully we have done. You can go and watch this VIP road and the Red Road and around the Kolkata Maidan roads where the mechanized mastic asphalt is actually laid. There your anti-skid stone chips are much lesser, only 5.6, pure 5.6 quarter-inch chips. Those are mechanically sprayed, mechanical chip spreader. With that, this gripping with the pneumatic tire roller, that is facilitated, and if the life of this anti-skidding, if it will not disappear naturally, it is much more durable than normal your dense graded paste. But that is very costly. That's why it is initial cost is I should also mention the initial cost is much higher. But if you see the life cycle cost, it will be much durable. It is 15 years plus, if not 20 years plus. So if you see the total life cycle cost, it is cheaper. And further to it, if you are adding the environmental cost, because by this time 20 years plus, you have to do normal BC mix around 4 to 5 times. Okay, so you can imagine how much the carbon emission was there. So you could avoid all this because of this in one operation. Okay, mastic asphalt is generally operated in the 200 degree plus. So thereby the initial carbon evaporation may be more, but here also the concept of the life cycle means total carbon footprint gain is much better than normal dense graded mix. So now about this, if you are having any questions, please.
Sir, what is the temperature during summer in Kolkata? During summer, is there a chance of flowing mastic?
There is that is the delicacy. You have to address all these in the mix design. Here lies the delicacy. There is, we have actually executed this mechanized mastic asphalt with this rainy season past. There is 3 rainy seasons already elapsed. Nothing, no fault has occurred. Okay, and if you carefully watch the VIP road last rainy season, up to where the Koikhali, beyond some from Ultodanga flyover to just prior to the Koikhali mode, 6.3 kilometer. That same VIP road, it was smooth, means flawless, without any potholes. And after that, this nightmare started. It came in the newspaper also. The same VIP road. There lies the beauty.
One more question. Why not we go for lesser thickness mastic asphalt? It is maybe we are using 12 millimeter in this carpet, and why not 12 millimeter mastic or 15 millimeter mastic?
It depends on the pavement, your structure calculation design.
We can do the BC, medium is with the
We can, but as we go lesser, like your 12 millimeter, that may not be enough to withstand whatever the wear and tear loads are coming of the heavy vehicles. That is fine. So 25, your idea is not bad. If we are just putting the wearing force only by the mastic asphalt, and that we may make the lesser thickness with that will be replaced by the DBM, sort of so, and which is actually the structural requirement of the pavement. Okay, so not bad, but you have to withstand. If you are actually aiming for the durability of the total road for 20 years plus, so you have also to keep in mind that the wear and tear also it has to last for that. It has to withstand for 20 plus years. So there lies your the structural design of this thing. So mostly 25 to 40 millimeter, or even in Europe, especially in Germany, they are using this mechanized mastic asphalt. They are calling it gas asphalt. They are using this mix in their expressway also. So and the German people came. They were actually mechanical engineers during the construction. This thing with the machine, they have actually those machines were imported here. They were telling in their country the gas asphalt last around. It is as good as a concrete pavement. 35 plus years. Can you imagine? So this is a very good opportunity, or rather mix. But we are not discussing at this lecture or presentation. We are not discussing. What we are doing normally. The dense graded bituminous mix, the DBM and BC, that we are discussing. But it is always welcome to discuss all these associated questions, whatever the questions are coming in your mind. Please. কোনো সমস্যা হয়নি. There were no problem at all. There is already there. You just next time when you visit the VIP road, you just carefully watch. There are markings there. No problem. It is absolutely smooth. It is as good as a BC surface or the SMS surface. It is there in the VIP road. Because quarter-inch chips, it is very less, and if it is uniformly spread, the required skid resistance is also there, and it will give this very smooth ride with pavement marking. All you can put very easily, no problem. There are a bit of your consumption of the your pavement marking, but that is mostly one-time cost, or some 5-6 years after you need to repaint it. So, but the primary goal is the durability of the road. No, that is addressed. Okay.
Sir, actually, how can we control the rut? Because we are putting
Will be coming.
more bitumen in the mastic, so there will be chance to
Rut. Yes, that I have told. If you put more bitumen, then the road will rut. The pavement surface will rut. If you put lesser bitumen, the fatigue cracking will come.
But in case of mastic, it doesn't rut.
Yes, because that's why I have told. There, the mortar that is formed with the harder grade of bitumen and the feeler line, and there this mortar strength is very high. From there, actually actually the shear strength of the mastic asphalt mix that comes. Okay, and that's why it is not that way rutted. And what Shubhal has told, that is not bad idea. If you put lesser thickness of the mastic asphalt, which is having the higher bitumen content, there will be lesser chances of rutting. But you have to ensure the wear and tear for this long years to come. That has to be addressed. Okay, so let us move. The amount of the bitumen which is added with the mineral aggregate are not totally utilized to act as the film to coat the aggregates. Okay, the amount of bitumen which is added with the mineral aggregates are not totally utilized. This is also very, very important and interesting point. The amount of bitumen what we are putting means incorporating in the mix to make a coating of the bituminous mix, which is actually acting as a glue. But the thing is that you may be knowing, but still I am trying to present it before you in an interesting way. Some amount of the bitumen is absorbed by the surface pores of the mineral aggregates. थोड़ा सा पी जाता है, थोड़ा सा बिटुमेन पी जाता है, ठीक है. एग्रीगेट में कुछ खा जाता है और पी जाता है, ठीक है. Because the surface pores are there, so from there that is called absorbed bitumen. So the total bitumen, some part, lesser part, of course, it is absorbed by the surface pores of the mineral aggregates, and the rest part, which we call it as the effective bitumen, that is the bitumen which is actually being utilized to form the film around the aggregate mineral aggregates. The aim of the proper mix design is to determine this effective bitumen content, because this bitumen is actually coming into play to create the coating film around the mineral aggregates. There lies the delicacy. So aim of the mix design is to properly determine this effective bitumen content and how much is absorbed, and the rest part is the effective bitumen content. So that is the aim, and this is the schematic diagram. This is, if you, I will request all of you to understand this mix design from the first principle, and this diagram is the basis for the first principle for understanding this. This is on the left hand side. It is the total mix. How it is total mix? It is the aggregate. You can see aggregates. They are coated by the bitumen. Okay, and even then some voids are left, which are called air void. Okay, you can see it is labeled there. And the total void from the total mix means total the schematic representation, the rectangle that is made, that is the total volume, and out of that the mineral aggregates volume means aggregates, those are being shown, is coated with the bitumen. And if you count this bitumen and the air void, those form together, that is the VMA. That is on the middle portion, it is being shown. It is just the aggregates are left. From this figure, it is different, that bitumen coating around the aggregates, those are left. This is lifted up. Okay. If you see, so this is actually the volume of the effective bitumen and the air void. It is forming the VMA, voids in mineral aggregate. Though understanding these concepts, these cannot be measured actually with some instrument like that. These cannot be measured. These are all analytical determination. But understanding these concepts are the key parameters of understanding and doing this asphalt mix design. And the third one, the right hand side, it is separated, stacked. How? It is interesting. Here it is total aggregate volume. This is a volumetric representation. Total aggregate volume, and you can see this part. This volume of the mineral aggregate is occupied by the absorbed bitumen. So we have to count that properly. And after that, it is the effective bitumen, and after that, it is the air void. It is the volumetric representation, schematic representation of the bituminous mix. Understand? With this, if you have any question, I can address. Tell me, please. Okay? Move forward. Should we move forward? Up to this is clear? No, it is the schematic. It is the schematic representation. It is just to make you understand, that's all. It is, the bitumen is lifted up. That's all. Actually, in the field, actual reality, the air void should be left in such a threshold limit so that the voids are not interconnected. Not interconnected. If it is interconnected, if it is beyond the range, upper limit crosses, the air void upper limit is crosses, then the voids get interconnected and the water and air can percolate. Okay. This is only the schematic representation. It's not in actual. Okay. In laboratory, the field compaction under the action of the heavy traffic, it is as per MS2. So MS2, when it was actually written with the US standard necessity, it is heavy traffic. They are calling it more than 1 MSA. In our country's perspective, it is much more than 50% or 20 MSA. It is called the your heavy traffic. It is simulated by preparing the Marshall mold with the 75 number of blows. I am talking about only the heavy traffic, because most of the roads which we deal, that is the state highway, the national highways, and even in the MDR, ODR also, the traffic crosses that in our state, especially in our country, because the roads are narrow, the number of the vehicles flying are much more, and there are problems of the crossing of the legal load limit, all this. So mostly the roads we are dealing, those are the heavy traffic road. And medium traffic road, that is 0.01 MSA to 1 MSA, it is simulated by 35 number of blows, and light traffic, that is less than 0.01 MSA, that is 35 blows. So number of blows with which we compact the Marshall mode, that differs depending on the traffic. But in our case, it is all heavy traffic, and it should be done with the 75 number of blows, if not more. So if not more is covered, it is actually more. It is covered in this code, IRCSP 35. The concept is called refusal density. Have you heard about it? Refusal density. Refusal density is nothing like that. It is also very interesting. You just increase the number of blows. What will happen from 75 to 100, 100 to 125, 125 to this? Because actually in the field, the road is withstanding lot of heavy traffic. So it has to be simulated with the laboratory compaction effort. So what we need to do, it is the number of blows need to be increased. Okay. In Marshall method, this impact, the laboratory specimen is prepared with the impact sort of hammer. Okay. But there are other in Vim method, it is kneading method. It is different, sort of so. And in superwave, it is gyratory. So the compacting effort that is put in for preparing the laboratory samples, those differs actually. What in Marshall method, it is impact. So you may question how it is the impact in the laboratory, how it is being simulated with the field condition. There are questions. There are questions from the time of the inception of this method. But this method, the laboratory preparation is done with the impact hammer only. There may be limitations of it. This is called superpave. Superpave, I have shown you superpave in gyratory compaction. Superpave method, gyratory compaction is utilized. But in the refusal density I was talking about, refusal density from the name itself. So with what is your concept is saying, with the number of blows increasing, the density should increase. There will be one point from where the density will be refused, bounce back. That is the refusal density. Okay, because with the number of the impact of the hammers increasing, the aggregates are pressures, and from there actually the density is getting reduced from the acme. Like curve is like this, from it's reaching to the top and then comes down.
Just like testing curve,
not Western curve, you can say the MDD OMD curve, right? Okay, so like that, you just visualize this. So that is called refusal density. In this code, it has specified for the heavy traffic road, that means 50 MSA plus, where the traffic are going on. The mixed design has also to incorporate this refusal density concept, and they have specified this. They have tested all the thing, and they have specified this as 250 blows instead of 75 blows. Okay. But we normally do it, but in the people we are dealing with the national highways, we should do it, but we are normally not doing it. And very interesting part, another interesting part. What is your feelings, general perception with if you do the mixed design with 35 number of blows and then 50 number of blows and 75 number of blows? Means as the traffic will increase, the bitumen content should increase or decrease with the increase of the number of blows for the asphalt mixed design. What it should be, what it normally comes. Tell me your perception. Share your perception. I am talking about the bitumen content. Bitumen content will increase as because it's dealing with the more traffic. Actually, it is contrary, reverse. There lies the beauty of it. So, for 250 number of flows, requirement of the bitumen will be lesser than 75 number of flows. How it happens, that I will discuss, show you. In USA, it is done by implementation. In USA already means for the heavier trafficked means highways. That is being done with the super pave. They have already incorporated changed from the Marshall mix design method to the super pave mix design. I've told you the type of the laboratory compaction in the super pave method is the gyratory method, and which is very close to the field situation or condition instead of the impact type of compaction for the Marshall method. That is the limitations of the Marshall method. Now steps for the Marshall method mix design. I will just discuss the steps. Aggregate gradation. I told you before determining the actually optimum bitumen content or design bitumen content. Prior to that, the main step is for the mix design is the aggregate gradation selection. How to do it? Let us proceed. For different dense graded mix, there is a definite range of the upper and lower. The specification in the code, like your 5th revision and IRC 111, they have specified the upper and lower range. Okay. So there is a ease. We don't have to do all about the aggregate gradation. They have advised us with lot of research and experience, permutation, combination, everything, with the foreign guideline, everything. And after that, the ministry has specified the upper and lower range of the aggregate gradation. With that upper and lower range of the aggregate gradation, it is mostly covered. What we have told that it should not follow the densest aggregate bracket. This is mostly followed. Now what we normally do, these ranges, I'm coming to this point. These ranges have been adopted after many research, experience, permutation, combination, and taking care of the factors narrated earlier. In the March specification, that is 5th revision and IRC 111, no criteria is laid down to select the aggregate gradation other than specifying upper and lower limit. In absence of that, normally what we do, the midpoint gradation is targeted. Okay, as the job mix formula. But that we do naturally. Okay, from the upper and lower. Now, out of my study and experience, I have sussed out, means what I am going to share with you. This method is not codified anywhere, but there are smarter choice in selecting this aggregate gradation. Apart from this midpoint targeting the midpoint gradation, those are interesting. Why? I am going to explain all this. I am not just telling that as I am telling you have to incorporate that, but I have some logics to convince you. What is that? Within this upper and lower, you just varying your aggregate gradation percentage, what we actually do it in the batch mix plant, you can adopt 3-4 gradations. Optimally 3-4 gradations will do. And in this 3-4 gradation, suppose we are doing the mix design of the bituminous DBM, dense bituminous macadam. There we know of grade 2. There we know normally the bitumen content is what? For the DBM grade 2, minimum bitumen content for that 4.5 we know. Just you adopt you choose just arbitrarily 4.5% of the bitumen. Okay, we are coming this part afterwards. First this aggregate gradation. How to fix the aggregate gradation? 3-4 gradation curves we have chosen. You adopt this 4.5% of bitumen and just determine the volumetric properties of that. These are the things. Gradation 1. You see the blue line, it is within the upper and lower limit with the variation of the different sizes of the aggregates. Okay, this is 1. This is 2. You can carefully see the specified sieve size that is passing. It is bit different from that. how it will help. That is the thing. And the third one is this one. Okay. And in this table, actually all this grading has been there. You can see for the bitumen content, all are kept same, 4.5%. And if we determine the volumetric properties, you see the air void for the first one is 3.87%. The other criteria is your stability, flow, those are determined. Okay. And air void is valid. In first case it is 3.87%, second case is 3.49%, and third case it is 3.60%. So it is variation is very less. But in the asphalt mix design, third numericals after the decimal, that also matters, because the changes are very small, but these small changes actually matter. And the voids in mineral aggregate that I have explained you and advised you to understand from the very first principle, from that schematic diagram. You have to understand. If you determine, I'll show you, there are formulas, analytical formulas are there. If you see carefully, the voids in mineral aggregate for the first one, though it is very less, it is a maximum for the first gradation. Okay? You carefully see that. Can you see the numericals out of it? Everybody can see now? So it is 13.83, which is more than 13.49 and 13.62. Okay? And the voids filled by bitumen is also varied. But here, my advice is that, and whatever my study and this thing, the voids in mineral aggregate is one parameter which is accommodating both your air void as well as the bitumen. Adequate, both are actually required to address this conflicting failures which we are facing in the bituminous pavement. That is fatigue breaking and retting. So if I will not say the maximizing the VMA, I will say optimizing VMA. If we optimize, having said optimizing, the other criteria also need to be satisfied, because other criteria is void in mix, that is air void, it is 3 to 5%. You see, all three are 3 to 5%. And the voids in the bitumen, all three have been satisfied. That is, the range is 65 to 75. In the rightmost column it is written that. But you see, for the first case, it is the best. The choice is best. So, if we adopt this for selecting the aggregate gradation, 3-4 aggregate gradation within the range, if we select, and with constant bitumen content near to the design bitumen content, if we determine all these volumetric parameters, out of all this gradation, if that one which will give the best VMA with satisfaction of all the other parameters, that would be your best gradation, aggregate gradation. Now you ask me the questions, means if you have got any doubt, tell me.
Sir, in grading 1, there is a parameter of stability.
Yes.
11.36.
Yes.
And after that 9.6 and 10.08.
Yes. You can see if for the gradation 1 it has come best.
তাহলে সেই ওই গ্রেড 1টা আমরা বেস্ট ধরছি, বেস্ট ধরা যায় যেহেতু স্টেবিলিটি রেসপেক্টে।
No, stability I am coming. So you want to say why not we will fix the criteria as the stability as well. Yes, okay, it is a good question. The stability and the flow are the Marshall parameters, but those are arbitrary. So far as the durability of the mix is concerned, out of the experience and the international research over the years, it has been seen that volumetric properties of the bituminous mix are much more important than these two arbitrary parameters of the Marshall parameters. So stability, if it is satisfied, it is required to be more than 9. For all thicknesses, it is more than 9. Fortunately, it is giving the best stability. No problem. But here, I want to optimize the VMA. That is the main criteria. Okay. So that is my study says that if you optimize this is one school of thought. Okay. because this VMA is accommodating both your air void as well as the enough bitumen content, which is addressing the two conflicting failure criteria. So it is one school of thought that you optimize the VMA. That will give the best aggregate gradation. So far, selection of the aggregate gradation is concerned. Understand? So from now onwards, I actually practice this since my last 20 odd years. After we have done in Bankura Durgapur specifically, there almost 45 kilometers of this BC and DBM. Extensively we have worked in the laboratory and tried to, and from there this slide has been taken, and the data also from there only. So we have optimized the VMA and we have adopted that aggregate gradation, not the midpoint aggregate gradation target. Generally what we do, midpoint gradation. Okay?
Is this grading was select?
That's why.
স্যার একটা কথা বলছি, এই যে ভিএমএ তো আমার একটা গ্রেডেশন চুজ করে আমি মানে দেখতে পাচ্ছি তিনটে গ্রেডিং এর মধ্যে ম্যাক্সিমাম ভিএমএ পাচ্ছি ফর গ্রেডিং 1। তাহলে এই গ্রেডিং 1টা ব্যবহার করেই তো আমি আমার আগের ক্রাইটেরিয়াগুলো অ্যাচিভ করেছি, স্টেবিলিটি ফ্লো অ্যাচিভ করেছি। তাহলে হোয়াই নট আমি ওইটা স্টেবিলিটি ফ্লোকে যদি আমি আগে যদি দেখি, যেটা ক্ষেত্রে স্টেবিলিটি এবং ফ্লো একটা ক্রাইটেরিয়া।
I have told you, Dhiman, that stability and flow, these are giving very arbitrary results.
তাহলে it may
Differ, yes. Volumetric properties will give you better, it will guide you better so far to achieve the durability of the and stability of the mix systems.
Optimum VMA বলছে ফার্স্ট গ্রেডিং that is 13.83 is that sir?
Yes.
Optimum range থাকে?
No, it's in the specification. When actually I'll read it out. Interesting thing. I'll read it out from this thing, advanced document. This thing, document number 673, NCHRP. Page number, if I will share this, page number 103. I will tell you. I'll read out this. Very interesting. Originally, Bruce Marshall, when it was invented by Marshall method, was invented by Bruce Marshall, recommended producing HMA mixture at the lowest possible VMA. See, it is written in the document, lowest possible, since this produced the densest, most stable mixture and required the lowest asphalt content. So it is the cheapest. Also, it is giving the initial this thing. Just a minute. Lowest VMA, since this produced densest, most stable and required lowest asphalt content. Lowest asphalt content means the cheapest, because this asphalt is the costliest component of this bituminous mix. Okay. However, engineers eventually realized that such mixtures often exhibited durability problems, and minimum VMA values such as those as given by the Asphalt Institute, means this MS2 Asphalt Institute, were established. They have established also in our 5th revision and IRC 111, there is a range of the minimum VMA. That's why this problem means criteria has been evolved, and they have been specified that minimum VMA you have to achieve this. Okay, so this is very interesting. Although the current Asphalt Institute version, now about the maximizing of your VMA, they are saying that this is actually not specified directly, but since you have specified the range of the air void and the voids filled by bitumen, and these two VMA is the addition of the voids filled by bitumen and air void, so indirectly we are specifying the maximum range as well. It is not, that's why I have used this word optimizing, not maximizing. You have to understand this. And if you actually use this method, that optimization of the VMA, with the satisfaction of the other criteria, automatically that is satisfied. So thereby my study and what you call it, this thing is there.
Eventually, for reading one, the VMA value is the highest value out of 3.
So we have adopted the gradation. This is gradation part. In mixed design, the aggregate gradation part is addressed like this. Now Divan, what you say?
ইনসাফে আপনি যেটা রিড আউট করলেন সেইটাতে বলছে মিনিমাম গ্রেডিং আমার ওইটা যেটা আপনি রিড আউট করলেন সেটা রেসপেক্টে আমি যদি দেখি গ্রেডিং 1 এন্ড
আমি দেখাচ্ছি। You see, here is the table from the IRC 111. Here your minimum VMA. Full screen তোমার কম্পিউটারে করা যাবে না, তুমি ফুল স্ক্রিন এখন এনেবল কন্টেন্ট করতে দিচ্ছে না, আবার ব্লক করে তুমি এটা দেখতে পাচ্ছ তো? পাচ্ছ না? ও বাবা গেল, এই আবার কি হলো? খুলতে দিচ্ছে না, তাহলে রিস্টার্ট করলাম, দেখো Partho, can you see now? Huh? Okay, this is the requirement of the minimum VMA that I was talking about. After this problem, when Bruce Marshall originally invented this method, he actually specified for the least VMA because it was incorporating the least amount of bitumen and it is creating your cheapest mixes production. Okay, but often the engineers have faced the durability problem. Okay, so though it appears to be initially very stable, but it appears means after that durability problem, then this actually it was felt. The thing I was just explaining, VMA, they have specified the minimum VMA. It actually varies with the year void and also the nominal maximum aggregate size, particle size. With lesser than nominal maximum aggregate size, lesser, actually the VMA requirements actually goes up, minimum VMA. You can see from the table, bottom table. Okay. Can you see now? Here it is 9.5 to 13.5. You see here for 37.5 it is 10 for 3%, and it is goes up where it is while it is going up means maximum nominal particle size. Now for 4% bitumen, same thing, and it is just 1% bitumen is added. That's all. 1% is added in the VMA, and from here to here, from 3 to 4, it depends on two parameters. One is air void, another is nominal maximum aggregate size. It actually goes up. So this is the thing. Means for a minimum
nominal maximum particle size কি আপনার ডিভিয়েট গেট গেটে তবে আমরা কি মানে তো মিক্সচার অফ গেট কি মানে ডিফারেন্ট পার্টিকেল সাইজ
You just follow the definition of the nominal maximum aggregate size. Actually, it is designated by the size of the mix. Like your for BC grade 1, grade 2, there are two particle size, means with which one, and SMA also, one is 9.5, another is 13.5. So on the top, it is being designated by that, and the mostly the ones your means in aggregate gradation, more than 90% which is passing, that sieve size is the nominal maximum aggregate size. The definition is there. You just carefully watch it or study it. So up to this we have discussed We have discussed the questions, we have taken the questions also. Okay. Up to this, whatever I have told, convinced? Any questions? Give me the book. But however, in this book, I have studied it from the manual, okay? In this book, Professor Khandal has written something different. Means maximizing VMA is not good, but I have told not maximizing, it is optimizing. And having the other parameters also satisfied. If it is said like that, there is no contradiction with this book, whatever it is there. So you have to study different study materials, research fact, and interpret with your logic. That is very important. Next I will come to the very important other aspects. You have to understand why we are doing the concrete mix design. We deal with two specific gravities of the aggregates. What are those? The bulk specific gravity and also apparent specific gravity. Okay? There in the concrete mix design, there are the work with the water. Okay? So the aggregates in their surface, they are having the surface pores. Mostly in the concrete mix design, the pores which are water permeable, if we calculate this volume and the total volume of the aggregates. One is total volume. I will go to the next slide, then you will understand. It is the schematic. Okay. There are pores inside the aggregates also. We are not counting. What is counting, what is being counted, that is the pores on the surface. Okay. Now you carefully see. One is white part, another is black part. The white part, including the black part, is the total, is the water permeable pores. But bitumen being much more viscous than water, you understand, the bitumen will not penetrate in the surface pores as much the water can penetrate. Agreed? So there are two volumes in case of the bituminous mix design. For the concrete mix design, if we deal with only one surface pores, that is water permeable pores, that is good enough. But for bituminous mix design, there is one extra definition of the specific gravity that is coming for the aggregates, that is effective specific gravity, apart from these two, bulk specific gravity and apparent specific gravity. Okay, that is the beauty, one of the beauty and delicacy of the asphalt mix design. We have to determine this effective specific gravity in particular. In some of the codes earlier, in 2001, one code of the IRC or the ministry specification, that is called Grave Group. I don't know, Sujan may be aware, being very senior officer. So there is one Grave Group. There the concept, there the effective specific gravity was written to be calculated like that. It is average of these two, means bulk and apparent, just average of these two. But you see, do you agree with me? Average means mostly 50% means it is assumed that bitumen will penetrate in the surface pores. 50% of the water will penetrate. Average, matlab time. Okay. Do you agree with this fact? It is just total is a rough average or assessment. But in actual it is not so. Bitumen will not penetrate in the averaging of this apparent and bulk. We have to determine this effective specific gravity. This is also one very important and delicate parameters of the asphalt mix design. So it is the its total schematic. Now there are two different. I am going in detail, so it is slow. So the speed is okay with you? Huh? Should I go faster? Faster? Shubha is nodding his head. Shubha is always fast. So this is first definition, apparent specific gravity. You see, there are, as I have already told, the surface ports are designated with your white and black, two things. But the specific gravity is the air-dried weight of the aggregate divided by the volume parameters, and weight of the volume replaced by that aggregate. Okay, that is the definition of the specific gravity. Now, what volume? That counts. Here there are three different volumes. One is total volume of the aggregate. Another is if you deduct the water permeable pores, and that is when you are actually counting the volume, reducing this water permeable pores, that means the volume part is the lowest. Okay, and thereby the apparent specific gravity, it is coming in the denominator, so it is the highest value. So apparent specific gravity, that way it is having the highest value. Understand? Normally we know apparent and bulk, that we know, and for the bulk we are not reducing any volume, of the surface force. It is the total surface force. Okay. So bulk specific gravity is having the least value. Okay. These are the definitions, and with the schematic it is shown like this. This is apparent, this is bulk. I have told you. In the bulk you consider the total volume of the aggregate, not any reduction of the surface force. And for the effective specific gravity, it is only the reduction will be done only for the part up to where the asphalt or bitumen can penetrate. So the water permeable pores, volume is 1. You have to differentiate what asphalt can penetrate. Only you reduce this volume. That is the point. There lies the delicacy of the asphalt bitumen mix design. There is all means you cannot do it by any instrument. लगा दिया, फिट कर दिया ये मीटर और निकाल के आ गया, ऐसा नहीं है. वो एनालिटिकली करना पड़ेगा. इसीलिए आपको समझना है कि क्या है, कॉन्सेप्ट आपको समझना है. दैट्स व्हाई आई एम डेलिबरेटिंग दिस मच. हमारा गला फाड़ फाड़ के चिल्ला चिल्ला के बोल रहा हूँ, ठीक है, टू मेक यू अंडरस्टैंड. ओके. Total volume irrespective, whatever the specific gravity will come, bulk. Water permeable, not all. You say surface pores only, not the inside of this thing. Okay, water permeable surface pores. Carefully you just tell, and that is apparent. Because the volume part is the least, so apparent specific gravity value will come the highest.
Surface force means such a water plus bitumen. Surface force.
Yes. Water means it is already containing the part up to which the bitumen can penetrate.
Effective means only where bituminous occupies the bath. Only that portion will be deducted. That volume which will be occupied by the bitumen.
Yes.
Total.
Yes.
Only bitumen.
So this is conceptual thing. You just understand first the conceptual thing. Okay.
That is effectively not that the average of apparent and bulk.
Yes. Not exactly the average. This arithmetic average of these two will be inaccurate. In previous documents it was mentioned like that, but it is inaccurate.
There is no contribution for internal parts. So whatever the white force inside.
That is actually water permeable force.
That is water permeable, but that is not surface water permeable.
No. Inside this, that is not penetrated. Means not accessed.
There is no
Water or bitumen cannot access the inside pores. Only we are talking about the surface pores.
inside white.
जो पीता है भाई एग्रीगेट जो बिटुमेन पी जाता है वो सरफेस पोर्स के जरिए ही पी जाता है, ठीक है. इनसाइड जो है वो पी नहीं सकता, ठीक है, वहां तक पहुंच नहीं है.
তাহলে কি স্যার আমরা বলতে পারি বাল্ক স্পেসিফিক গ্র্যাভিটি মাইনাস অ্যাপারেন্ট স্পেসিফিক গ্র্যাভিটি ইকুয়াল টু
No, it is not say so. भाई इतना चिल्ला के मैं गला फाड़ के समझाया तुमको, फिर भी ये बोल रहे हो. अभी वो डिटरमाइन कैसे करते हैं वो दिखाएंगे. हम आते हैं भाई, या तुमको पूछना चाहिए कैसे डिटरमाइन, जैसे उन्होंने पूछा कैसे डिटरमाइन करेंगे. आप तो बोल तो दिया भाई कैसे एक मीटर लगाया और आ गया हमारा पूरा डिजिटली आ गया डिस्प्ले, ये है वो है, ये अपरेंट है, ये बाल्क है, ये है. While we are doing the concrete mix design, we are determining the apparent and bulk. Okay, up to this you are familiar. So the new part is the effective specific gravity determination. Okay, this is a valid question that how do we determine the effective. Dear भाई इतना तो आसान नहीं है, इसलिए बोला ना, इट्स वेरी डेलिकेट थिंग. हम लोग कर दिया क्या, रास्ते में जाता है पब्लिक सोचता है क्या है, बिटुमेन कम देता है और उखाड़ के चला जाता है, रोड बनाता है, ये चला जाता है. इट्स नॉट सो इजी. इट इज प्रोफेसर पांडे यूज्ड टू टेल दैट इट इज नॉट लेसर देन डिजाइनिंग ए 10-story बिल्डिंग. इट इज एज डेलिकेट एज दैट. एस्फाल्ट मिक्स डिजाइन डिजाइन करना कोई आसान चीज नहीं है. नाउ calculation of the different specific gravity. Okay, some calculations are being shown. These are the formulas by which you can do A, B, C. What is A? A, I have to, can you see in the this thing? Is this visible now? A is the overdried sample in the means air. Okay, this is constant of the aggregate. Okay. Now mass of the SST sample in the air. What is SST? Surface saturated dry. How it is done? It is just dipped into the water and then is pulled out, and with the wet towel or something that just only the surface water particles, those are removed. Okay. Then how does it, what does it imply actually? In the surface pores, water is already filled. So you are counting that part of the water also, what is inside the surface pores. You see it is 1009 gram. So it is more than what is ever dried. So 9 gram is the weight of the surface water. Okay. Now mass of the SST sample in water. Normally it is dipped in the water and it is getting the weight. If you are taking the weight from the Archimedes principle, it is buoyancy. Because of the buoyancy force, it will come naturally lesser. So it has come 655. Okay. So this is GSB. That means bulk specific gravity is A minus B minus C. That the specification means definitions that we have discussed. This is the analytical thing. You have shown these are the two determination of the apparent and bulk specific gravity, and also absorption. Absorption means water absorption. I'm talking about. With this formula, we are determining, and we are determining this as per IS 2386 Part 4. Okay. This is not something astronomical. This is the thing what we are doing in the laboratory. Okay. With this, up to the apparent and bulk, we are familiar. We are doing it in the concrete mix design. So, and the formula I have also shown, and with this, we are doing it. Okay. Now comes to your question. Ma'am, how we determine the effective specific gravity? See how the effective specific gravity can be found out. Effective specific gravity of the aggregate gradation. I am talking about the entire aggregate gradation, because not only one size of the aggregate gradation, entire gradation I am talking about. Because of the from size to size, the bulk specific gravity we all know it differs a bit. Okay, but in that case for the aggregate gradation we have to average it out as per the weighted average actually with the percentage. Weighted average I think you know, because you have to count the percentage of the aggregate in the aggregate gradation that you have. Means if it is 40%, you have to give 0.4 out of the total 1. This weight you have to give. If it is 60%, you have to give 0.6. This is the weighted average. Okay. Specific, like your bulk specific gravity and your apparent specific gravity, these are supposed to be the properties of the aggregate. If the query is not changed and the geological variety is not changed, the surface pores are same, almost same. From the aggregate gradation, if it is the proportion is changed, it may change. Okay, but if the aggregate gradation is kept constant and the source is remaining the same, we can means logically presume that these are the aggregate properties and these are not changed. Okay. Similarly, your effective specific gravity is also the property of the aggregate gradation. It is supposed to be the unique for one gradation. If it is not, the source is not changed. Okay, and the aggregate gradation is not changed. That is written on the first line. It is a parameter of interest of the asphalt mix design. For asphalt mix design, it is a point of the interest for determination of that. It can be determined after the determination of the theoretical maximum specific gravity determination as per ASTM D2041. How to determine your effective specific loose move mix has been put in a jar actually. There are series of jars you have seen. So actually the partial vacuum is created. This is the mix is being poured, and after it is very made it loose, not compacted, because we need to separate out all the voids. Theoretical maximum specific gravity, that means zero void theoretically. Now, huh? Liquid, nothing liquid, no, it's water only. It's water only. Water. सब पानी है और क्या है? कोई केरोसिन नहीं, केरोसिन से तो बिटुमेन पिघल जाएगा, मतलब ये जाएगा, निकल जाएगा ना. And this is the standard ASTM ASTO T209. You search in internet, you may find it. Okay. Otherwise, in this book, it has been demonstrated. The methods are demonstrated here, and also in YouTube videos. I have taken this from the YouTube video, but this is very authentic. As per the ASTO code, they have done it. This is nothing. The concept behind this that we are trying to measure the density of the mix without any void, zero void. That is theoretical maximum specific gravity. All the series of the jars and whatever you seeing in this video, that is for the creation of the vacuum. It is not directly put on the jar with which you are doing. It's for the safety thing. We have for the Panagarh Ilambazar project, actually we are doing this, and this is also being shaken also for 15 minutes or like that. For one amyl arrangement is there for this partial vacuum is created, and also it is shaken to make all these voids out of the mix also. And some of the enthusiastic lab assistants, they have done it with the hand, with patting the jars and like that. And since the vacuum was actually created, because of the air pressure, it burst in the hand itself. So this experience we also having. I have got that video also. So this is what this thing you see is very meticulous method. It will be shared with you. You just see how it is done. All that readings has been carefully put. The basics of this is to measure the density of the mix without any void. All these vacuums are being created, all this patting and the shaking is to make the air bubbles inside the mix out of the system. That's all. And determination of the density is same. This Archimedes principle. That's all. It's specific gravity. It's not density. What is the difference between that?
Actually, is created to ensure the air.
To expulsion of the voids.
Expel the air.
Expel the air bubbles. What is there in the mix? That is the reason why we actually apply the vacuum. Okay. Should we go forward? This is okay? You just watch it, huh? Okay. It is. And this is the results of that. Means mass of the sample in the air, that is 2500. Mass of the flask filled with the water, only not with the mix. This is 7119. Mass of the flask plus the sample filled with water. This filling up to the fullest this inside volume. That is a challenge. How it is done? That is you just watch the video, then it will be shown. Without any bubble, air bubble inside it. That is very careful about it. Okay. That needs some sort of skill of doing this. So that is the last one is E8697 gram. Now the theoretical maximum specific gravity, that means the weight in air divided by A plus D minus E. If you carefully watch this, A is the mass in the sample in the air plus D is the flask minus E. E is the total, means weight of the mix poured inside the water plus the flask, and rest of the volume is filled with the water. So it is the weight in the water of the mixed, water replaced by that. So and it is volume. So it is the volume of the mix actually. It is just incorporated there in the denominator. This is how the maximum theoretical specific gravity is determined. Okay. Next. Determination of the effective. We have our main aim is to determine the effective specific gravity. These are the steps how we determine the effective specific gravity. Now, the result of the theoretical maximum specific gravity GMM of the loose mix can be found out most accurately when the bitumen content is near to the or close to the design bitumen content or a bit more than that. There are two methods of doing this for determination of the theoretical maximum specific gravity. While doing the determination of the optimum bitumen content in the asphalt mix design, what we do, we just vary the bitumen contents from for your DBM. We start with 3% or 3.5%, then 4%, 4.5, then 5.5, vary. And with this variation of the bitumen content, we just measure the parameters like your volumetric properties, air void, VMA, VFV, and also the stability, flow, and also the density. We just measure these 6 parameters. Out of that, 3 are volumetric parameters, 3 are just measurable parameters, including the density and also Marshall properties, flow and stability. But while determining this GMM, theoretical maximum specific gravity, normally people doing with the variation of the bitumen content, they are determining the GMM for each and every your asphalt content. But MS2 is saying that whatever is in bold font it is written, it is saying that GMM result, it is a experimental determination of the result, okay? So there are errors and these things are associated with the determination of the experiment, but it gives the best result where it is close to the design bitumen content. Now tell me why it is. Suppose the design bitumen content for the DBM is 4.5%. if we add 2 to 2.5% bitumen in the aggregate gradation, will the surface pores are saturated with the whatever they have the hunger in absorbing the bitumen? Will that be satisfied? No? Agreed? Okay. So, if we test the GMM with 2.5 to 3% of bitumen content, that will not give you the most accurate GMM. When it will be most accurate? Asphalt Institute, after lot of experiments and everything, they have done this testing and they have recommended it will give the best result when it is close to the design bitumen. That is the beauty. Now I will show you this thing. This MS2 7th edition, page 52 or 3, something like that. Clause 5.4, page 52. You just carefully read out this clause. It is very well explained how this delicacy of what I am saying. Thus, determination of the GMM will be best, will give you the best result when it is closer to the design bitumen content. The reason I have explained to you, you are convinced? The logical key, logical mone hocche to. And after that, this the range I have told for if you are doing it for the say DBM grade 2, then range should be 4.4 to 4.6. If you are doing it for BC grade 1, means normally it is 5.2, so 5.1 to 5.3 with this range you have to do. After finalization of the aggregate gradation by optimization of the VMA as described earlier, GMM should be determined with the bitumen content close to the design bitumen content or a bit more than that. Okay, this is for the GMM calculation. Now you have got one GMM, not all the GMMs. Normally people do GMM, they are determining for 4-5 experiments for all the variation of the bitumen content and they are doing the averaging like that sort of thing. Or they are doing calculating the GSE, because this is the formula of the GSE. GSE is the effective specific gradation. The GSE is explained schematically here. You see the surface pores, these are exaggerated obviously. The white portion is the water permeable, but we are interested to calculate this much. The arrow is being shown here. This much bitumen means pores volume we are interested in calculating. Illustration of the effective aggregate volume. Effective volume is volume of the solid aggregate particles plus the volume of the water permeable pores not filled with asphalt. Not filled with asphalt. This is actually, this part we have to deduct from the total volume. Previously I was said it wrong. Means pores minus, you have to deduct it from the water permeable pores to means asphalt permeable pores. So we are interested in deducting this white portion. Okay. That's what it is being analytically by formula it is done like that on the left hand side. GAC, that means PMM, that means percentage of the weight of the loose mix, that is 100, minus PB, that is the asphalt content in percentage totally. Say if it is 5%, then means 100 minus 5, that is 95, and PMM is the percentage of the total loose mix, that is 100%. Okay, divided by the GMM. GMM we have determined. Okay, minus PB by GB. PB is the percentage of the asphalt bitumen percentage. or 4.5 or 5, whatever, divided by, means out of the total mix you just say 5, divided by the specific gravity of the asphalt. Generally it is come 1.02, 1.01 like that. Here also I will say, though it is not specified in IS 73, okay, the specific gravity determination of the asphalt, but it is better to determine it. If it is more than, it is coming more than 1.03, 1.035, there are chances of the adulteration, because this is a adulteration practice. Means some stone dust are being mixed out of taking the bitumen wet, and they are incorporating it to manage the wet, to compensate the wet. And if these adulterations are incorporated in form of the stone dust, naturally the specific gravity of the bitumen will go up. So that will give you some indirect idea that bitumen is somehow doubtful. But the main test is the purity test, that is the solubility test. Okay. With the trichloroethylene, what we test, 99% plus the soluble it should be. This is additional information. It's very difficult, very difficult, very difficult. You have to do some test. So with this formula, we can determine GSE. Now, corresponding to 1 GMM, you will determine this GSE, and the GMM which will give the best accurate result, naturally GSE will be most accurate. This is done analytically. Now we have got the GSE of the aggregate gradation, which is supposed to be the property of the aggregate gradation, and it is not changing. It is unique. Same thing. Otherwise, with the corresponding to different bitumen content, you are determining GMM differently, and you are determining GSE also, and then you are doing the averaging of the GSE. You agree with this point? By this averaging, we are actually accumulating some error, and this method is better. So this is one thing, and let me tell you, in this book, Professor Prithvi Singh Khandal has written this method is best method, and let me take this honor to share with you in one probably 564 paper. He has written one paper along with Professor Vidagavan. There's a perpetual payment on this. ISC paper was there, and I have pointed out this, not errors like that. From quoting this MS2, I have pointed out this one. This GMM gives the best result when it is nearer to. It was not covered in the paper. He acknowledged in the. This is a written document in IRC papers. That document I am having, but I have not taken it here to share with you. If you are interested, I can share with you. And he acknowledged that you are, Mr. Chattoraj, you are right, that this is actually the best method. And in the book also, he has written that. And in most, my experience is that now I am associated with this industry in form of a pan-India basis. What I am saying, this method is not being done by anybody. This is not, unfortunately, it is not known. When I am pointing it out, they are actually eye-opening sort of thing. Oh, this is there. So this is also one very good thing if you are minutely reading it, the manuals or the codes, the whatever the Asphalt Institute manual, experts and the legends like Professor in this field, of course, Professor Prithvi Singh Khandal and Professor Vidagavan. So this is very minute thing, but this will give you accurate result. Any questions on this? Of the aggregate gradation pay. Yes. We are interested in that aggregate gradation, not the individual thing, because that will make your job harder. Okay. Now, with this GSE, you just find out GMM, naturally if you change the bitumen content from 3 to 3.5% to 4% like that, we are changing. Naturally, as because the specific gravity of the bitumen is lesser out of the total mix, as you increase the bitumen percentage, asphalt percentage, the GMM, the theoretical specific gravity, it will increase or decrease. Tell me. Bitumen is increasing its specific gravity with respect to the other aggregates. So it will decrease. Naturally, that will get. But we have done one good thing, that we have determined one GSE. Now we have to determine for each and every your asphalt content. We don't have to repeat this test again. That shown. Now you have to determine with the analytical formula that is being shown here, and that will give you better result. Understand? These are very small things. Like you have said somebody, how much it will after third digit to the decimal it may vary. How does it matter? But it will matter. It will matter. In case of the asphalt mix design, it will matter. So with this formula, you will calculate GMM for the different your asphalt content. Okay? Any questions? Yes. তখন GSE you have to calculate the GSE analytically, and this GSE, these are I will show you in the tabular form of the GMM for all. Yes.
Actually, we did a reverse. Actually, you are doing reverse process, sir. You are doing it for different content first GMM, then average GMM, like that.
Average GMM. So we average it out. We determine average GSE actually.
Average GSE.
These are formula quoted from the most authentic book. This one, MS2. Okay. I will also show you the kind of reading I do it. Each and every line by line, I just pose questions myself and interact with legions and experts like Professor Khandal, Professor Pandey, and write down the answers also in the book itself. So when it will be recapitulated, all these things are coming. So this is how all these documents you can show it. I'll share after this presentation. I'll show. And if you want to, if you get interest, naturally you will do that. And this is a very interesting thing, very delicate thing, very interesting thing. And this is again the schematic of the one side, the left hand side it is the weight side, and the right hand side is the volumetric side. Okay. It is being shown, and this is all about the aggregate. This is total aggregate, and then some part of it is occupied by the absorbed binder, and this is effective binder, the upper part, and the top part is the air void. Flexible to some extent because your bitumen is not that rigid. When load comes, it flexes a bit, but not that much your dense-graded bituminous mix deflects. So this is again the phase diagram, schematic. Now I'll go directly to the table. Then I'll come back. This table, can you see this? Tell me, Shubha. Here, what I have told, see, I'll just explain. Here it is bitumen content 3, 3.5, 3, then 4, then 4.5. What I have told. Then GMM. Now I have calculated this GSE totally 2.827 with the method I have already told. because I have determined, because I have near to the design bitumen content, that is 4.5. 4.5 I have actually determined the GMM as 2.622. Okay. This GMM we have used to calculate it by formula GSE, and that is 2.827 for all the varieties, all these cases. Okay, and this GSE we have used in calculating the GMM for with different bitumen content that I was telling. Okay, you will get this presentation and then you will read it carefully. Okay, all this with the calculation it is being shown, so that it will be easier for you to understand, relate the things, how it will be done. GMM টা করেছি, and corresponding GSE we have. না 4.5 এ কিছু আসবে না, দেখো 2.827 GSE value for all cases this is constant. Only GMM is varying, and that is also actually calculated by formula, not by experiment. Okay, and rest of the parameters you just calculate with the formulas. कोई formula नहीं, same formula. Okay. These are all the values of that Bankura Durgapur road way back in 2007-8 where I've done it. All this data of that, so realistic data. This is what is spelled. GMM was determined by the testing of the bitumen content 4.5 and was found to be 2.622. Okay, and with this value of the GMM we have determined GSE as 2.827. In the table it is there. For this particular aggregate gradation, source remaining same, it is unique, a property of the aggregate gradation. Thus for all variation of the bitumen content in the above table, it is same. Again, GMM has to be determined for different bitumen content. This time it is not required to go for the testing because of that, because in that case it will be inaccurate. I should not say inaccurate, but lesser accurate. It is not required. In this method it is not required. It is lesser accurate. Yes, barbar korat kono dokkar. Yes. So I think I could explain my points with the logic, the engineering logic. Why this method is more accurate. Okay. The test gives the best result only when the bitumen content is close to the bitumen content. Thus, this time it is determined by the formula shown on the earlier slide analytically. Compacted bulk density. Now you have to actually determine the bulk density of the mix. This is another challenge. It is said in the guidelines or the documents, codes, if the water absorption, that means surface pores are not much, it is within 2%. The Asto T275 will Asto T166 is the method, means water dipping, that's all, and surface saturated dye method is okay. If it is more than water absorption is more than 2%, that means the surface pores are much more, then the paraffin coating method is actually required. There are other method also which is in modern laboratories that is being used, that is core lock method. That I've not covered here because at that time core lock was not that popular. I didn't get those in the document. Now it has come. The determining of the GMB is the bulk specific gravity of the mix Marshall mold. It is being determined in SST method. It is as per IS Asto T166 or ASTM T2726. All these documents you can find it in the internet, you search, but I have not given you. If you don't find, then you tell me, I will share. Okay. Should I explain this? You are all determining the Marshall mold bulk density. You are doing it in lab. How do I bring it? You are just SST condition means but in air you just taking the weight, then surface saturated dry condition, and thereby after that you are just giving this in formula. Just a minute. So with this formula, in SST method you can determine the bulk density determination of the Marshall molds. Okay, it is also has to be done very carefully, because if you don't do it, it will not give you the actual results. Okay, and while validating the field performance, field properties after doing it, means laying it in the field, while taking the course after 24 hours, while we have all done. I don't know what time after what time you have taken in the site, but ideally it should be after 24 hours and without traffic being allowed. But in our situation, in the road condition or the traffic condition, we cannot wait. Immediately after laying, and when the temperature drops down around 60, 70 degrees Celsius, we have to open the traffic. But that better if we do it just after 24 hours, we have to take the course, and also we have to determine the bulk density of it and compare that with the GMM, and thereby determining the percentage compaction. What is that? It should come 92% plus. Okay, and thereby the air void is 100 minus 92. It is 8%. It is with the compacting equipments, that means rollers. It is supposed to come 92% plus the compaction, degree of compaction plus. And after the effect of the traffic line, over the years, around it is from case to case it varies, but from 1 year to 1.5 years, like that, it should come near to 3 to 4%, and that is called secondary compaction. The primary compaction is of course by the roller, okay, and the secondary compaction from this 7 to 8% air void, it comes down to 3 or 4%, okay, and in the mix design, you should all take care of it. Now, if it will come down, drops down to less than 3%, what will happen? কমে যাবে কি হবে? Rutting, that plastic deformation, that the phenomenon that I was calling. So there lies the delicacy. You have to design the thing in such way, the asphalt mix, that air void should not drop down below 3% to 2.5%. All these volumetric parameters I was talking about, trying to explain before you, those are the very small ranges you have to actually attain. If it goes beyond that, this rutting, either rutting or the fatigue cracking, it will occur. And next method is the paraffin coating. This is also I'm not going to explain, because it is one dipping into the paraffin, and this was paraffin coating done so that because of the larger absorption, percentage of the absorption, water will get penetrated. So thereby with the paraffin it is blocked. The main aim is to determine the bulk specific gravity of the mold of the mix. That's all. Compacted mix. Okay. And this table I have already explained to you. And details of the calculation for the computation of the air void, they determined bulk density of the specimen cost with different bitumen content are compared with the respective theoretical maximum specific gravity, just now I told, of the mix with the same bitumen content. Air void cannot be measured with any instrument, but it is analytically determined in terms of the volumetric percentage of the total mix as 100% minus the percentage compaction. I have just told compacted bulk density of the mix compared with respect to the theoretical maximum specific gravity. Like for 3% bitumen content, it is in that table. Here it is just stated. For 3% bitumen content, 100 minus 2.452 divided by 2.687, that is 8.75%. For 4%, it is come down to 7.5%. This is how the air void is calculated. If you see the table, you can relate. The volume in the mineral aggregate is another important volumetric property measured in terms of the percentage of the total mix as 100% minus compacted bulk density of the mix into the aggregate. There is another, this VMA calculation is there, VMA calculation formula is there. Formula is that 100% minus compacted bulk density into the aggregate percentage of the mix divided by the bulk specific gravity of the total aggregate. It is the total of the effective, it is the total of effective bitumen content, bitumen volume and the air void volume. Means VMA is what? It is the summation of the volume of the bitumen, effective bitumen, not total bitumen. It is the effective bitumen and the air void. But the void in filled by bitumen, it is also VFB. In America, it is called VFA, void filled by asphalt. Here we call it void filled by bitumen. Is the third volumetric property measured in terms of the volume percentage of the VMA. It is expressed with comparison with the VMA, not the total mix. The VMA percentage, what is expressed in terms of the total mix volume. Air void is also that, but VFP, it is compared with the VMA only. It is expressed in terms of the percentage of the VMA. So it is VMA minus VIM and air void divided by VMA into 100%. Okay. I am just a bit fast here, but if you see, I have explained all this. If you see, you can understand. And bulk specific gravity for all the sizes, it is generally average, weighted average is done. Some important points. This is a very delicate thing which you will not find in that I was telling you. The questions that came in my mind, I have written in the questions. Also try to find out the solutions, means answers for this. I have written that. I have put that in the this presentation. We are studying it. This slide is some food for thought. I am leaving it up to you to read it out. Very interesting points are there. Not related directly to the asphalt mix design, but these are deep studies. Okay. So I am leaving it up to you. Food for thought. These are the graphical representation. There are 6 characteristics we are actually finding out with the variation of the bitumen content, and we are plotting it with the variation of the bitumen content. These 3 are the arbitrary things, which not the bulk density. Bulk density, though it's not specified, but it is general customary that we determine it bulk specific density of the Marshall mold and plot it against the bitumen content. And the rest 2 are the flow value and the stability. We plot it, and then these 3 are the very important volumetric properties. One is air void, another is VMA, another is void filled by bitumen. Okay, these 3 are very important. As Diwan was asking, why not stability and flow, this thing? But it has been seen, observed, and international research facts are there. From these 2 parameters of the your stability and the flow, the volumetric properties are much more important. If you satisfy the volumetric properties properly, the durability of the mix is really matters. Okay. Now determination of the ultimate thing. After determining all these graphs and everything, plots and everything, ultimate, the end product is we are interested with. One is aggregate gradation that we have discussed with already, and the next part is the design asphalt content. MS2 says that it will not be right to depend on only one parameter for selecting the design asphalt content, because one single asphalt content cannot address all the issues to the highest extent at the same time. Okay. It also says if one single parameter has the maximum influence on the overall performance of the mix, it is the air part. It is the winding mix. That means air part. Okay. First, it has said we should not depend on only one parameter. But after that, it also says if one parameter influences the total performance of the mix maximum, that is the air part. So, previously we used to do it, all these parameters we determine, and then density, stability, flow value, and then air void. These 4-5 parameters, we take the corresponding bitumen content and make the average. But presently it is being done, and it is the international practice, that an acceptable range of 3 to 5% air void is used. With this range, 4% air void is considered to be the best initial estimate to determine the design bitumen content, which will balance the mix performance. Balance because it has to address many criteria, which are many of which are conflicting to each other. So it is the balancing. The asphalt mix design is sort of, you have to do a very good balance within a very narrow range. That is all about it. So it is seen that 4% air void is considered to be the best initial estimate to determine the design bitumen content. Not 4% exactly, you may vary it a little bit depending on the other criteria, but it may be taken as the initial estimate. Fine tuning after that is done on the basis of the other parameters. Previously, the optimum bitumen content was derived, that I have already told, on the basis of the average bitumen content corresponding to the maximum compacted density of the mix, maximum stability, and 4%. These three parameters corresponding bitumen content, and we are doing the average. But it has been said that we should actually get the design bitumen content with respect to 4% air void, and then validate this other parameters with respect to this bitumen content. And this is a better approach. And in super pave method also, which is the outcome of the modern research, also says so. Our IRC 111, which has been drafted by Professor P.S. Kandal only, so it has also specified that. You may ask for that we should have some IRC guideline reference. So in IRC 111, it has been stated that with respect to 4% air void, we actually need to determine the design bitumen content and validate that with this. Now I have incorporated this equation, fatigue equation of the pavement design. It is actually the fatigue equation of the pavement design. As per IRC 37, 2018, okay. There are equations with respect to 80% reliability and 90% reliability, okay. Here you see there is a factor C. C factor, you are seeing that? And C factor is depending on the mix properties. That is effective bitumen content and the air void. C is defined as a 10 to the power m. M is 4.84 within bracket effective bitumen divided by air void plus effective bitumen minus 0.69. So this is the factor which actually will depend on the on the mix design parameters. Now with this, some in ISC 37 there are some guidelines for more than 20 MSA. Some you have to actually assume some values of the air void and effective bitumen content, and with that the charts I'll be showing. These charts, you are familiar with these charts? Okay, these charts actually has been determined with some specified range that has been specified in ISC 37. This C factor and effective bitumen content and air void that has been determined. But now with this fatigue equation you have determined. Naturally, in IIT PAVE this calculation will matter, and there are inputs for this one. Now you just validate that this strain is coming, and as per your design this thing, whatever strain is actually there, so that is safe. You have to validate. But thing is that when you are doing the actual mix design in the field, you need to get back to see the pavement design and check the C factor with what air void and the effective bitumen content. It has been actually, the fatigue equation has been designed. Now whatever actually, it may differ naturally what you have considered during the time of the pavement design, there the mix design was not there. So now in the mix design it will in most of the cases naturally it should be 100% cases it will differ. But you need to validate with this field data what you have considered in the pavement design, which is not the industry practice, unfortunately. Generally not done. In our case it is not done. In some of the, what I have seen, to my experience as for now, in the NHI projects, those are done, but not properly, not correctly it is being done. Actual validation of this design, mixed design properties, that has to be rechecked with the pavement design. So that's why I have incorporated this slide. Could I make you understand what I have told? বোঝা গেল কি বলতে চাইলো? আমাকে কিন্তু এই প্যারামিটারস গুলোকে আবার রিচেক করতে হবে, ভ্যালিডেট করতে হবে যে যেটা ফ্যাটিগ ইকুয়েশন we have considered. Okay,
modified সিটারে আসছে বাদ করতে হবে।
হ্যাঁ সিটা বাদ
ওখানে এই
হ্যাঁ pavement designer fatigue equation is
just stay within the limited range.
Yes, you need to do the IIT PAVE calculation once more. Yes, this graph you are familiar with. This is called narrow graph. It is there in MS2. Actually, on the left side of this, the bitumen, these are the different parameters with respect to the different bitumen content. Now, on the left side of these are on the lower range, and on the right side of this, which are black, totally black, it is on the more than the upper range. But within the hash portion, of the bitumen content, all the parameters are satisfied. So you can see this is the range in which all the parameters are satisfied. So this is called narrow graph. You need to put on this graph and see the range on which the bitumen content. This is all the parameters are satisfied. Are we doing this? Huh? Need to do it. And that is what is my presentation ends here. But I also need to say one thing that I have told, incorporated this C factor, whatever with the bituminous mix, and this I have already talked, the diffuser density as per the latest code of the IFC. We also need to check for the higher volume roads where the traffic is more than 50 MSA. Okay.